JavaScript closures made easy. In this video, I'll explain closures in an easy to understand way. I'll also show you some practical and useful examples so that you can use closures in your own code. Why should you learn closures? Here's some reasons why you should learn closures. The closure pattern allows you to use JavaScript in new ways. For instance, you could use closures to hide variables of a function and selectively expose methods, otherwise known as encapsulation. You could use closures to ensure that a function is only called once. You could use closures to make functions more memory efficient. Closures are a fundamental concept of functional programming. Without closures, higher order functions and currying is not possible. Questions around closures are almost guaranteed in most JavaScript interviews. Understanding how closures work will allow you to answer questions with ease. So what is a closure? I'm going to give a definition of a closure, and it's not going to make any sense at all. And then I'll follow up with a few practical examples. And once we've gone through a practical example, the definition will make perfect sense. A closure is when an outer function returns an inner function. The inner function is then executed in a different scope, and the inner function continues to maintain access to the outer function's variables, even though the outer function no longer exists. At this point, if you don't already understand closures, this definition should be very confusing and make very little sense to you. And that's okay, because I'm going to take you through a few closure examples step by step. And after each example, I'll come back to this definition. So let's look at a simple example. In this example, I've got a function called greet on line 1 and a variable called name on line 2. The greet function returns a new function on line 4. This function that gets returned on line 4 is an anonymous function. We call it an anonymous function because it doesn't have a name. Notice how the inner function on line 4 doesn't have any parameters. Instead, it references the outer function's name variable on line 2 and logs out a greeting with the outer function's name variable on line 5. To call this function, I'm declaring a variable called greeting on line 9. And the value of the greeting variable will be a function because the greet function on line 1 returns an anonymous function on line 4. And since the greeting variable is a function, because it is the inner function that was returned from the greet function, I can invoke it as shown on line 11. If I proceed by running this function, we get the result, "Hi John." At face value, you might think, what's the big deal? The inner function is returning a simple greeting. But if you analyze the function in more detail, you might notice some odd behavior. For instance, on line 5, the inner function is referencing the name variable that is in the outer function. This in itself isn't odd, because this is simply making use of lexical scope, which is to say that a function can access a variable that was defined outside of that function. But then if you look at line 9, you'll see that I declared a variable called greeting, and this variable holds the inner function that was returned on line 4. In other words, the inner function has returned and the outer function no longer exists. Moreover, at the time that the inner function is invoked, it references the outer function's name variable, even though the outer function no longer exists. So how is the inner function able to reference a variable in the outer function if the outer function no longer exists? The simple answer is closures. A closure ensures that when an inner function references variables in an outer function, those variables in the outer function will continue to be available to the inner function at the time that the inner function is invoked, even though the outer function would have returned and would no longer exist at the time that the inner function is invoked. The word closure might sound confusing. Why is it called a closure? It's called a closure because the inner function closes over those variables in the outer function which the inner function references. Another way of saying this is to say that the inner function is enclosed over the variables that it references in the outer function. In other words, when the inner function returns, it gets returned as a package that includes the inner function and the variables that the inner function references in the outer function. Let's go back and look at that definition again. A closure is when an outer function returns an inner function. The inner function is then executed in a different scope, and the inner function continues to maintain access to the outer function's variables, even though the outer function no longer exists. Let's look at the code again and cross-reference it with the definition. A closure is when an outer function returns an inner function. Here in the code, we have an outer function on line 1, and it returns an inner function on line 4. The inner function is then executed in a different scope. Back to the example, and we can see that we're invoking the inner function in a different scope on line 11. We're not invoking the inner function from within the outer function. We're invoking the inner function from the global scope. And the inner function continues to maintain access to the outer function's variables, even though the outer function no longer exists. Back to the example again, and we can see that we are invoking the inner function on line 11. At the time of invocation, the outer function on line 1 has already returned. It no longer exists, and we can see that the inner function references the outer function's name variable. The key takeaway point is that a closure allows the inner function that is returned access to all of the variables in the outer function which the inner function references, even though the outer function would have been destroyed by the time that the inner function is invoked. Let's look at a second example of a closure, which is a bit more practical. In this example, I've got a setCount function on line 1 with a number variable on line 2, which is set to 0. On line 4, an anonymous inner function is returned, which increments the number variable by 1. Then, on line 9, a counter variable is declared which holds the result of the setCount function invocation. And the result of the setCount is the inner function that is returned on line 4. So once again, counter is a function and not a value. And finally, on lines 10, 11, and 12, the counter function is invoked 3 times. Before I run the script, what do you think the output would be? Let's run the script and see. The result is 1, 2, and 3. Why? Because the inner function increments the number on line 5. And the closure allows us access to the number variable that was declared even though the outer function was destroyed. And each time the counter function is invoked on lines 10 to 12, the value of the number variable on line 2 is incremented. So the concept of a closure, which is that an inner function has access to a destroyed outer function's variables, is demonstrated clearly here. Even though the outer function no longer exists, the inner function continues to have access to the outer function's variables. Let's look at a more challenging example. This type of example is quite common in interviews, so stick around. In this example, I've got an add numbers function on line 1 with an empty numbers array that is declared on line 2. Then on line 4, a for loop iterates from 1 to 3, and for each iteration, it pushes an anonymous function on the array. Then the numbers array is returned on line 10. On lines 15 to 17, the anonymous functions in the array at positions 0, 1, and 2 are invoked and logged out to the console. Take a minute to look at this code. What do you expect the output to be? If you expect the output to be 1, 2, and 3, you'd be wrong. Let's run the script and see. Well, that's confusing. The result is 4, 4, and 4. Why? The for loop uses a var variable, and a var that is used in a for loop in JavaScript is wasted. What this means is that when the code is executed, the JavaScript interpreter creates a var I declaration on line 3. In other words, the I variable is declared outside the for loop, and the variable is then mutated during each iteration. This means that after the for loop runs to completion, I will be equal to 4. But why 4? Think about how a for loop works. Many of us use a simple for loop on a daily basis without truly understanding how it works. If you have a look on line 4, you'll see that the for loop takes 3 expressions inside parentheses. The first one is the initial or initializer expression. And what it does is to initialize the for loop. The initial expression will only run once. And in this case, it creates an I variable and sets it to 1, which is also the starting position of the for loop. The second expression is called the condition expression. This expression will evaluate for each pass of the loop. It will evaluate to true or false. And as long as the expression evaluates to true, the for loop will continue running. So here you can see the for loop will keep running as long as I is smaller or equal to 3. The last expression is the increment expression. It will increment I by 1 after each pass through the loop. So even though the for loop only does 3 passes, it will still increment the value of I after the last pass, because that's how the increment expression works. We now know what the value of I will be after the for loop runs to completion, but that still doesn't explain why each of the values returned from the getNumbers array on lines 15 to 17 is 4, 4, and 4, instead of 1, 2, and 3, as one might expect. To understand this, let's go back to line 5 in the for loop. For each iteration, we're pushing an anonymous function to the array. If that sounds odd, it's not. You can push a value, an object, or a function to an array. We're not pushing I to an array. If we did that, we would push the value of I at the time of iteration to the array. Instead, we're pushing an anonymous function to the array that will return the value of I at the time of invoking this anonymous function in the array. And at the time of invoking this anonymous function on lines 15 to 17, the loop would have already run to completion. And by the time that the loop has run to completion, I will be equal to 4 because of the way that the increment expression in a for loop works. The only remaining question is, how can each anonymous function in the getNumbers array access the value of I? Think about what's happening when we execute the anonymous function on line 15. We're invoking an anonymous function from the global scope on line 15. Add numbers on line 1 is an outer function that returns a bunch of inner functions because the numbers array that is returned on line 10 contains a bunch of anonymous functions that are essentially an array of inner functions in the add numbers function. Each of these inner functions in the numbers array is accessing the I variable which is in the add numbers function scope. And at the time that each inner function is invoked, the add numbers function no longer exists. Yet each of the inner functions maintains access to the I variable that is in the add numbers scope. So all the conditions for closure have been met. This is a classic closure. So that's how the anonymous function in the getNumbers array can be invoked from the global scope and return the value of I. So in conclusion, the result is 4, 4, and 4 because of various factors that combined. The var in the for loop is wasted. The value of I after the for loop ran to completion is 4 because of the way that the increment expression works. Invoking each anonymous function returns 4 because the anonymous function returns the value of I at the time of execution. And each anonymous function has access to the I variable because of closures. Before we move on to the next example, let's have a look at the definition of a closure again. It should start to make a little bit more sense now. A closure is when an outer function returns an inner function. The inner function is then executed in a different scope, and the inner function continues to maintain access to the outer function's variables, even though the outer function no longer exists. This example had a closure, or rather multiple closures, because the outer function returned an array of inner functions that maintained access to the outer function's variables after the outer function was returned, and each one of the inner functions were executed from the global scope. If this still sounds confusing, that's okay. Closures is a difficult concept to grasp. Go back to the first and second examples of the video as many times as you like. I also highly encourage you to play around with the code snippets. In the previous example, 4, 4, and 4 is returned from the array functions. In a real-world example, we'd probably want 1, 2, and 3 to be returned. How can we keep the closure but return 1, 2, and 3 instead? There's two very simple and easy ways to do this. The easiest way to do this is by simply using let instead of var in the for loop. Let me show you. I'll change var to let and then I'll run the code again. And now we get 1, 2, and 3. How is this possible? It's simple. When let is used in a for loop, let will have a unique binding for each iteration. Think of this as there being a unique I variable for each iteration. The second way that we can achieve a unique binding for each iteration is by using an IFE, or an immediately invoked function. To do this, we wrap numbers.push in an immediately invoked function like this. And so what we're doing here is for each iteration, we pass the I variable to the immediately invoked function, which receives a function scope variable called index. And this index variable is privately scoped to this function and will have a unique binding for each iteration. And running the script that uses the immediately invoked function will also return 1, 2, and 3 as expected. The next example is a variation of the previous examples we looked at. It's another popular interview question, so I encourage you to watch this so that you can understand how it works, because understanding it means that you can answer any variation of this question that comes your way. On line 1, we've got a create callbacks function with a for loop on line 2. And for each iteration, we create a setTimeout function. The setTimeout function is essentially a function that will run another function after a specified time. So to create a setTimeout function, you need to pass in two arguments. And the first argument expects a function. And the second argument expects the time in milliseconds to wait before the setTimeout function will run. So if I pass in 1000 milliseconds, it will run after 1 second. For the first argument, we pass in an anonymous function, which is just a function without a name. Think of this as an inline function. Okay, so back to the code on line 3, where we create a setTimeout function for each iteration of the loop. And what you can see is that this is a very simple setTimeout function that will just log out the value of I. And each of the functions will run 1 second apart. And finally, on line 9, the create callbacks function is invoked. Now, before I execute the code, what do you think we'll see in the console? Okay, so let's run the code and see what the results are. The results are 4, 4, and 4. But why? I'm going to explain this example a bit faster because we already explained the similarities of this example in the third example. If you want a more in-depth explanation, please refer to the third or earlier examples. On line 2, we have a for loop that uses a var. And we know by now that a var in a for loop is wasted, which means that the I variable is declared above the for loop, and that the I variable is mutated in each iteration of the for loop. And the value of I will be 4 after the for loop ran to completion. Because even though the for loop runs from 1 to 3 for a total of 3 iterations, the increment expression runs after each iteration, meaning it will run after the third iteration and set the value of I to 4. If you're wondering why we're seeing 444 logged out to the console instead of 1, 2, and 3, the reason is that at the time of the for loop iteration, it's creating 3 setTimeout iterations. Those setTimeout functions won't run at the time of the for loop iteration. The first setTimeout function will run after 1 second. The second one will run after 2 seconds, and so on. But the for loop will run to completion in just a few milliseconds. How does this work? Well, when the create callbacks function is invoked on line 9, it will run the for loop. During each for loop iteration, we create a setTimeout function. Remember that we're just creating the function. It's not invoked during any of the for loop iterations. When we create a setTimeout function, it is placed on the job queue, which is what the JavaScript framework uses to keep track of when to run jobs. The create callbacks function will run to completion almost immediately. Once this happens, JavaScript will keep running the event loop, which keeps running continuously to check if any code needs to execute. It will also check the job queue to see if there's any functions that need to be executed at a specified time. And if they do, that function will be executed at that time. The real question is, how does each setTimeout function have access to the I variable? The answer is, you guessed it, closures. In the first example, I explained how a closure allows an inner function to reference an outer function's variables, even though the outer function no longer exists. And in this instance, setTimeout is the inner function because it is accessing the I variable which is hoisted outside the for loop. It's important to understand that closures are created when functions are created, not when they are invoked. And because a closure was created when the setTimeout function was created, this enables the setTimeout function to access the I variable at whatever time the setTimeout function will run. Now that we're done with most of the theory around how closures work, I'd like to focus on 3 practical examples that you can use in your code. These practical examples are actually a lot easier to understand than the previous examples. Using the closure pattern in your code will solidify your understanding of closures. Moreover, the next time someone asks you how to use closures, you should be able to give them some practical use cases. The first practical example is a very useful pattern to know. Think of the following use case. You want to expose a count object with increment, decrement, and getCount functions. And each of these functions have access to a private variable that keeps track of the count. In other words, you want to implement encapsulation, which is to say that you want to hide or make an object state private and only expose its methods. And closures is a simple and effective way to do this. Let me show you. I've got a count function on line 1, and on line 2 I declared a count variable which is scoped to this function. Then on line 4, I'm returning an object with an increment function on line 5, which mutates the count variable on line 2 by incrementing its value. The decrement function on line 6 decreases the value of count, and the getCount function on line 7 simply logs the value of the count variable out to the console. Then on line 11, I create a new variable called counter, which is equal to the object that is returned from the count function. In other words, the counter variable will only contain the object returned from the count function. The count variable on line 2 is not returned from the count function, which means that this is a private variable, and only the increment, decrement, and getCount functions in the counter object on line 11 has access to the counter variable. This is all made possible through the use of a closure, because as you remember, the definition of a closure is when an outer function returns an inner function, the inner function is then executed in a different scope, and the inner function continues to maintain access to the outer function's variables, even though the outer function no longer exists. And in this example, we have one or more inner functions on lines 5 to 7 that are returned by an outer function on line 1. These inner functions are invoked in the global scope on lines 13 to 18, and each of these functions continue to have access to the count variable that is defined in the outer function, which no longer exists at the time that these functions are invoked. So we have successfully used the closure to implement encapsulation in JavaScript. Let me show you what the output of the script is if I run it. And we get 2 because we're running the increment function 3 times and the decrement function once. In the next example, I'm going to show you how you can use a closure to ensure that the code in an init function is only executed once, regardless of how many times the init function is invoked. This is a very useful pattern with various practical applications. For instance, you could use this to ensure that a database connection is only initialized once. On line 1, we have the init function, and on line 2, we have an initialized variable that is set to false. Then on line 4, we return a function. And in this function, there's a simple if condition that checks if the initialized variable is set to true or false and acts accordingly. On line 5, if the init function is set to true, we log a warning out to the console to say that the code has already been initialized and nothing else happens. And if initialized is false, which should be the case whenever the initialized function is invoked for the first time, lines 9 and 10 will run, which will effectively set the initialized variable to true, and any code you need to run, such as initializing a database or whatever you want to do, can run over here. This is a closure because on line 14, when we set the initialized variable, it is equal to the function on lines 4 to 11 that are returned from the init function on line 1. In other words, we have an inner function that is returned from an outer function, and this inner function references a variable in the outer function that will no longer exist at the time that the inner function is invoked on lines 16 to 18. Another very useful use case for closures is memory optimization. Imagine a simple function called findByIndex, and in this function, we declare an array called numbers with 1 million items. And this function will simply return an item at a specified index in the numbers array. The problem with this function is that every time the findByIndex function is invoked, a new numbers array with 1 million items are created. It takes a lot of time to create the numbers array with 1 million items every time that the findByIndex function is invoked. Let me show you. We're invoking this function 4 times on lines 11 to 14. And we can see that the first time that the function is invoked, it takes 56 milliseconds. Then the second time, it takes 35 milliseconds. The third time, 38 milliseconds, and so on. Let's see how we can use closures to ensure that the array is only created when the function is invoked the first time. So here I changed the function to use closures to ensure that the numbers array is only created once. We have a findByIndex function on line 1, and then the numbers array is created on line 2. Then we return an inner function on line 4, which takes an index parameter, and this index parameter is then used to get the item in the numbers array at the specified index. On line 13, I create a find function that is equal to the inner function that is returned by the findByIndex function. When this function is created on line 13, the numbers array will be created. However, when I invoke the find function on lines 15 to 18, the array will not be recreated, no matter how many times the find function is called. Once again, this is done through closures. We have a closure because there's an inner function on line 4 that references a variable defined in an outer function on line 2. And by the time that the inner function is invoked from the global scope on lines 15 to 18, the outer function no longer exists. Yet the inner function still has access to the numbers variable that was defined in the outer function. And if we look at the script that logs out the time, we can see that the numbers array is only created once, which improves performance. If you found this video helpful, give it a thumbs up and please let me know in the comments below. If you didn't find this video helpful, let me know why in the comments below. Thanks for watching, and I'll see you next time.